So for this video, we'll be showing more examples on prime factorization, specifically the two methods, the factor tree method and the continuous division method. So let's start. Now before we start with the examples, feel free to pause the video so you can try it on your own. So we start with the 2-digit number 75. So when we apply factor tree, we simply, again, we can branch this out, and clearly this one has a factor of 5. So we've put 5 out here. Then if we divide 5 by 75, we will get 15. So this one is 15. Now observe that this one is already a prime, so we leave that alone. Next, for this one, observe that we can still factor this one as 3 and 5. Now these two are already primes, so we are now ready to represent 75 as a factor of primes. So we have 75 is equal to 3. Since we have 2 5s, we write 5 times 5, or 3 times 5 squared. And this is our final answer. Let's go on to a larger example. Say we have 130. Clearly, since it ends in 0, then it has a factor of 10. So we can branch this out as 10 and 13. Now since 13 is already a prime, we leave this one alone. Now next, this one, we can still factor this one as 2 and 5. Now these two are already primes. Oops. So we circle them out. Now we are ready to represent 130 in its prime factorization. So we have 130 is equal to 2 times 5 times 30. And this is the final answer. Just a quick note. The reason that I'm using this symbol more, this refers to like a dot product. It's like multiplication that will be used further in higher math. It's like it's called scalar multiplication. And the reason, why I don't use this symbol, the times symbol, is because it's sometimes confusing since it looks like a variable, an x variable. So I avoid using that. So just take note of that. Now let's try a 4-digit number. Say if we have 5040. Since it ends in 0, we can factor it, the 10 again out here, and the 504. Now this one, we can factor this out as 2 and 5. So these two are already primes. For this one, observe that 5 plus 0 plus 4 is equal to 9. So this one is divisible by 9. So let's try to divide it by 9. This would give us, this is 5, this is 4, and this one is 6. So it's 56. So we can decompose this as 56 and 9. Yep. Now this one, we can decompose this as 3 and 3, since 3 squared is 9. And these two are already primes. Let me just move this out here to clear some space, and let's resize it like that. Now for 56, since it is an even number, we can factor out 2 here. So we have 2 and 28. This one is already a prime, so we circle that out. Now for 28, we know that since it is an even number again, we can factor out 2. This one is 14, and 14 is simply 2 times 7. So these are primes. So we can now write 5040 as 2 times 2 times 2 and times 2, since we have 4 2's. Then we have 2 3, so times 3 times 3. Then we have times 5, and we have times 7. So yeah, 4. Oops. Sorry about that. So we have the 4 2's, the 2 3's, the 5, and the 7. So yep, to simplify this, we can write this as 2 raised to 4 and times 3 squared times 5 times 7. So this one now is the prime factorization of 5040. Now let's go on to continuous division. Let's start with 125. Now first, we can observe that it has a factor of 5, or it is divisible by 5 since it ends in 5. So we can put 5 out here, and we have, let's try to divide it. So give us 2 and 5, so it's 25. Now this one is also clearly divisible by 5. So we put 5 here, and the outcome here is 5. So we have 5, 5, 5. So we know that the prime factorization of 125 is 5 times 5 times 5, or simply 5 cubed. Let's go on to our next example. Say if we have 210. Now first, observe that it ends in 0, so clearly it is divisible by 2. And that would give us 105. Yep, 105. Now since it ends in 5, then this one is divisible by 5. And that would give us 21. Since 5 times 2 is 10, this one 5. Yep. Then this one, since 2 plus 1 is equal to 3, so this, we know that this one is divisible by 3. So we put 3 out here, and 3 divided by 21 is 7. And all of these are primes already. Oops. So now, we can write 210 and its prime factors. So 210 is equal to 2 times 3 times 5 times 7. And that is its prime factorization. Now let's go on to our last example. Say if we have 900. Now since it ends in 2, it ends in 0, it is divisible by 2. So this one is 450. Since it is divisible by 2 again, since it ends in 0, we write that. And this would give us 225. Yep, so it's 225 times 2 give us this one is 4, 5, and 4. Yep, correct. Now for this one, since it ends in 5, then clearly this 1 is divisible by 5. So we put 5 out here, and dividing that would give us, let's try dividing that. So 5, 4, 2, 5, and this one give us 45. Now 45, since it ends in 5 again, then we can divide it by 5 again. So that would give us 9, since 5 times 9 is 45. And clearly 9, since we know that 9 is divisible by 3, we write 3 out here, which will give us 3. Now all of this are primes already. So we can now express 900 in its prime factors. So we have 900 is equal to 2 times 2, since we have 2 2's here, 2 3's here, so times 3 times 3, and 2 5's here, so times 5 times 5. And that would give us 2 squared times 3 squared and times 5 squared. And that is its final answer. So that's all for our example. So yeah, just remember that in the factor 3 method, the advantage of that is that you can branch the factor 3 out depending on how you like it. So like in this example, if you can first see that it is divisible by 10, then you can put it like that. But here it's more strict. So that's the advantage of the factor 3 method. But the advantage of the continuous division method is that it is more simple and it's more continuous. And when you finish the method, the prime factors are already clearly visible, since the method is more efficient as it starts with all the prime. But you can also do that with the factor 3 method. Like for instance, we have 900, you can do that too, and that will give us like that, like all. So it depends on your preference. But I highly suggest that you practice both methods, so you can use the other method to check if your first preferred method is correct or not. And so that's all for this video.